Okay, so over the last couple days, we have been setting up proportions and solving, right? We've done like large triangle to small to large, left to right, right to left. I'm going to show you another way to set up that will work, okay? You can still go small to large, large to small, right to left, left to right. But with this theorem, you can compare pieces, which may be easier for some of you. Each problem is going to be different, but I'm going to let you kind of decide how you want to go about solving each of them. So I'm going to give you the theorem to start, and then we'll go through and decide how we want to solve each problem. So if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. And I'll explain what all that means. So if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So we have a triangle, ABC, and then we have a line that goes through ABC, and we're going to call that EF. Which are the triangles we've been working with, right? Like we've had two triangles in one. Okay, so if EF, which is the line, is parallel to BC, and you use little arrows to show parallel. Do we remember that from IM1? Yeah? Okay. So if EF is parallel to BC, then the pieces that they create are going to be proportional. So AE is going to be proportional to EB, and AF is proportional to FC. So I can compare the pieces. Now you can still compare small triangle to big triangle, but in some cases comparing the pieces may be a little bit easier. So we're still setting up a proportion and solving. So if you can set up the proportion, I am confident that you know how to solve it. The hard part is setting it up. Okay, so if those lines are parallel, they have to be parallel, then you can compare the pieces. So that's going to be the tricky part as we solve some of these. If they're not parallel, then we can't use pieces. We have to do small triangle to big triangle or left to right. Okay? All right, so let's look at a problem. So we're going to solve for the variable. So I have 1 plus 4x, 5, 20, and 4. And because you see true triangles, you could do small to large, or we can compare the pieces because those two lines are parallel. Okay? It doesn't matter which way we choose. Now, comparing the pieces might be easier because if you go small to large, so small triangle to large, you'd have to add them together. Small triangle to large, you'd have to add them together. If we compare the pieces, it's 1 plus 4x over 5 and 20 over 4. once our proportion's set up, what do we do from there? Cross multiply, right? So if I cross multiply, I get 4 plus 16x equals 100. Subtract 4 from both sides, so 16x equals 96, and you get x equals 6. 96 divided by 16 gives me 6. Okay, so it's just another way to set it up. Are we okay with that? Yeah? Okay, why don't you and your group set up and solve this one? So take a second and solve that with your group. Will someone tell me what their proportion is? What'd you do for your proportion?
4x minus 3 over 18 equals 4 over 8.
Good. 4x minus 3 over 18 equals 4 over 8. When you cross multiply, you get 32x minus 24 equals 72. Okay. I'm going to add 24 to both sides. So 32x equals 96. X equals 3. Not too bad? Okay. So when you look at this one, I want you to decide what the best option is to solve it. So you have a couple options. One of the ways we've been solving is easier than another way, but I want you to decide with your group what the best way to solve it is. You'll need to set up the proportion and solve. So don't solve it yet. I want you to figure out what your proportion is with your group. Okay, so draw it and then figure out what your proportion is. So as I walked around, everyone's looking at this one a little different. So we're going to look at it two ways. Okay? If you have to compare the pieces, which is what the triangle proportionality theorem says, I'm missing this piece. Do you agree? Okay. Now you can find that. You have enough information. I know the whole thing is x plus 5, and I know this piece is 6, so I'm going to find this piece. Any ideas on how to do that? X plus 5 minus 6. If this whole thing was 10, and this piece was 6, what would this piece be? 4. 10 minus 6 gives you 4, right? So x plus 5 minus 6 is the same as x minus 1. Okay, one more time. X plus 5 minus 6 is x minus 1. If I add 6 back to this, you end up with x plus 5, which is the whole length. So I'm going to show you two ways to set it up. So the first one is finding that small piece. And now we can compare our pieces. So x minus 1 over 6 equals 2 over 4. And you're going to cross multiply. Or, since you already know the large piece, you can compare pieces. Right? The problem is we have to know this piece. So the small triangle over the whole thing equals the small triangle over the whole thing. But you still have to know this piece. I think we've missed that in group F. Okay, so you can compare the small triangle to the big triangle, or you can compare the pieces. Either way, you're going to end up with the same answer, and this one's easier because I have less x's to deal with, right? So 4x minus 4 equals 12.
Yes.
Add 4 to both sides. 4x equals 16, x equals 4. Did anyone set it up different and still get x equals 4? Yeah? How'd you set it? No? Okay. And if you solve this, you're still going to get x equals 4. Okay, so whether you compare the small triangle to the big triangle or compare the pieces, you just have to make sure you're consistent. Now, there is one additional way I can set this up. Because these two lines are parallel, I could also do 6 over the whole thing, which is x plus 5. What does 6 match with on the other side? 4. And then what's the whole thing? 6. Because x plus 5 matches with the whole thing, which is 6. All three of these proportions will give me the exact same answer. So as long as you are comparing the same pieces, you're okay. Okay, so I'm going to give you another one just like it. You decide how you want to set it up. And let's see how we do. Okay, so let's see. Someone give me their proportion. Go ahead. X over 21 equals 6 over 14. I will take that. Does someone have something different that they want me to verify? No? Everyone used that proportion and or didn't do it? So again, go ahead.
21 minus x over x equals 8 over 6.
Yep. 21 minus x is this piece here. So 21 minus x over x equals 8 over 6. Perfect. I will take that. Now, you have to be careful because this works because these two lines are parallel. If you don't see parallel lines, you need to compare the small triangle to the large triangle. Okay? Either way, both of those will work. Let's cross multiply. So 14x equals 126. And when I divide by 14, I end up with x equals 9. You like that way better? This way is going to give you the same answer. So as you were working, I solved the 3 up here, or the extra 2. You get the same answer no matter how you set it up, as long as you are comparing the correct things. Are we okay with that? Okay, there's one additional problem that we're going to see, so I want to show it to you. Please don't freak out until we talk about it. You're already freaking out. Okay, calm down. Just draw it. You're going to be fine. We'll survive. Just try it. We're gonna be okay. I'm gonna do it with you. It's okay. I promise. It's gonna be okay. Okay, one thing that we really need to look for is that these lines here are parallel. Because those lines are parallel, the pieces are proportional. Okay? So what can I compare? So I can do x over 14. And then I have to compare the same piece on this side. So 3 over what? 7. Okay, so I did x over 14 and 3 over 7. It just has to be the same pieces. So 7x equals 42. X equals 6. You could have found this piece here by doing 14 minus x, and then you could have compared these pieces. So there are a lot of ways you can set it up. You just have to be consistent with what you're using. Because once you set up the proportion, are we confident that we can solve it? Yeah? Okay, good. All right.